so I won't go over it in detail. All right, so let's look at this first one here. So this first one, so it says combine expressed as a single logarithm. So it just wants you to move everything together. And so we're going to be using our log rules. And so here we're going to be using the power rule. So we're going to pull this one in here. You know what? Let me pull up the power rules and stuff. So I have them all for you, and that way you can see them. We're in no rush today, which is good. Everyone's like, rush through it. Let's go. I want to go back to bed. I don't care no more. No, I get it. All right, let's do this. This will have them. This one. There we go. All right, so I want the other log rules too. Here we go. This is what we want. All right, so make sure you have these handy, right? So make sure you have these log rules handy. And so we're going to be using these log rules, these laws of logarithms right here to make this a single function. So we're going to be using this one to move the c. So we're going to use this to move the c in here. We're going to be using, I just move in all the negative signs and make these positive. That way I don't have to worry about things. And so we'll just move this. So we're going to move everything in using this rule right here. And then since everything's positive, we can just use this rule right here. Okay. So that's how we're going to do this. Oh, that's from 4.4. I think I pulled this from the wrong section. I think I grabbed the 2.6 ones at 126. This is the same thing. I think yours is 5.4. Let me double check. Let me open up the right ones for you guys. Nope. Yours would be 5.4. It's actually, I just stole the same thing. It's just a different set of problems. Okay. So this is 5.4. You just write all these down. All right, so here, let's do this. So we're going to move this 5 in. We're going to move this -1 in, just because I like to do it that way, and move the 4 in. So here I'll have log base b of x to the 5th plus log base b of y to the -1 plus log base b of z to the 1/4 power. Okay. And so once we do this, now we can just multiply. So I have a plus, and a plus. So I can just multiply this all together. So I'd have log base b of x to the 5th, y to the -1, z to the 4th power. So remember, the pluses turn into multiplication. And then the last thing I want to do here is just kind of clean it up. So be log base b, x to the 5th can stay on top. Y to the minus go on the bottom. And notice if we kept the negative here, it would have gone on the bottom anyways. So I just like doing it this way. That way I can always just multiply everything. Just makes my life easier. Do what makes the most sense for you. And then here we have the 4th root. So remember, z to the 4th is the same thing as the 4th root of z. And so this is what you would plug into the test. Okay. All right. So here, this is how we do the first one. All right, for the second one here, we're going to find the inverse. In fact, let's hold off on 2 for a second and let's do 3, just because we have all those rules in our head, and then we'll come back and do 2. All right, so let's do 3. So here we're going to just do the opposite, right? As a sums and differences logarithms. And so what we're going to do here, and so here we'll do the first one. And so we're going to have log base a, and we're going to have the cubic root. So here, let's go ahead and do this. So we log of a. And then here we're going to just write a squared b over c to the 5th to the 1/3 power, right? That's what the cubic root means. And let's go ahead and stuff in the cubic root. So it'll be the log of a of 2/3 plus or times b of 1/3 times c of 5/3. Okay, does everyone see where I get these? So if I multiply, if I raise something to a power, it's just like multiplying them. So 2 times 1/3 be 2/3, 1 times 1/3 be 1/3, 5 times 1/3 would be 5/3. And then the next thing I'm going to do is write everything up top. So this would be a log base a to the a of 2/3, b to the 1/3, and then c I'm going to write to the minus 5/3. That way it's always up top. Everyone see that? No one's complaining at least. Oh, I'm not going to have enough room for what I want. Should have written just a teeny bit smaller. Actually, here, let me just move this over and I'll write smaller next time. So this becomes log of a, and then we can split it up. So it'll be 2/3 plus log of a b to the 1/3 plus log of a c to the minus 5/3. Actually, I only need one more line. All right, and then we can just write out what this is, and then I'll have lots of room for the other one. So log of a to the 2/3. Well, this cancels each other, so I just get 2/3 here, right? Because log base a of a, that cancels, and that gives us 2/3. This 1/3 I can pull out, so I can pull out, it would be plus 1/3 log of a of b, because here I'm just using this rule and opposite, right? I'm pulling this one out. Okay, and let me show you, hold on, now that I have this up, let me show you, is it 3? Yes, 5/3. So here, I'm using this property here. Log base a of x is x. So here, log base a of 2/3 is 2/3. Okay, and that's in 5/3. Okay, so we have this, and we have 1 plus this. And then here we can pull this out front, so we'll have minus 5/3 c, or minus 5/3 log of base a of c. And so here we've written this as a sum. All right, so let's go ahead and leave that, and let's do this one. And this one's actually, in my opinion, a little bit easier since there's no b's here, right? So it'll be exactly, you just pull stuff apart. So here, what I want to do is make everything on the same thing. So I have this, I'll have m to the minus 3rd power and n to the minus 4 power. Does everyone remember getting m to the minus 3rd, n to the minus 4? Base b, sorry. So the whole thing, yeah, so this right here is the answer. So the point of this is actually to expand it out, make it longer. Just to see if you remember the rules, because you need the rules to solve problems. All right, so here we're just going to expand this out, and then we can convert multiplication into addition. So we log base b of a plus log base. Somehow that did not go very well. Log base b of y to the 5th plus log base b of m to the minus 3rd plus log base b of n to the minus 4th. And here I'm just using this one. Here I'm just using this rule. If I have a times b, that's just the log of a plus the log of b. And so since I have here log of a times b, or a and y and m and n, is just log base b of a, log base b of y. And then the last thing we want to do here for this problem is you want to pull out your exponents. And so here we'll have a, so log base b of a, the exponent here is 1. Here I have the exponent of 5. Log base b of y. Here I have an exponent of minus 3, so it'll be minus 3. Log base b of m. And here I have a minus 4, so it'll be minus 4. Log base b of n. Okay, And once again, the whole thing right here would be your answer. All right. Do I have more logs on? Oh, we have a lot of log stuff on this stuff. But let's go ahead and let's do our inverse problem. Okay. All right. So here we're going to take this and we want to find the inverse. So we're gonna take this. We're gonna find it. We're gonna graph it. So we're gonna find the inverse. We're gonna find the domain and range, and then we're gonna graph. And I'm gonna make this a little bit smaller so I can write a little bit cleaner. So that way we have plenty of room to do this. All right, so remember our rules for inverses. I don't even remember what section inverse was. Oh, give me a second. Let me find what section inverse was. It was 5-1. Oh, we did inverses? Yes, that's why we did inverses. And somehow I'm missing the page where we did it. Oh, here we are. Da, 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 da. Can you show the answer? Oh, yeah, I can show the answer to the one while I'm looking. There you go. And then here, I'll put this down below. Okay. Oops. I did not go down below. Hey, you. Do as I ask you to do. Of course not. All right, so here we go. So here we're going to find the inverse. So remember to find the inverse, we're going to write y. This is 5-1, page 4, in case you're wondering. So we're going to write y as a, we're going to switch out f of x for y. We're going to interchange x and y. We're going to solve for y if possible. And then we're going to write y equals f of x. And then we just check it real quick, just a quick check. And then I'll teach you how to find the domain and range and all this stuff. Okay, so let's just do that. All right, so here, we're going to do our first step here, which is to write y equals, zoom on in so I have loads of room, 5x minus 3 over 2x plus 1. Step 2 is to switch all my y's and x's. So here we'll have x equals 5y minus 3 over 2y plus 1. Step 3 would be to solve for y again. And so we'll have to do that. So the first thing we want to do is multiply over. So we'll have 2y plus 1 times x equals 5y minus 3, which gives us 2y x plus x equals 5y minus 3. And then we're going to move the 5 over. So it'll be 2y x minus 5y. And then we'll move this over. So it'll be equals minus x minus 3. And then we just pull out the y. So I'll have y equals to 2x minus 5 equal, whoops, y not equal, y times, sorry, y times 2x minus 5 equals minus x minus 3. And so that will give us y is equal to x minus 3 over 2x minus 5. And then the last step, step 4, is to write f inverse of x is equal to minus x minus 3 over 2x minus 5. So here we found the inverse. Can we find that in Wolfram Alpha? I bet you. I bet you can. So let's test it together. Oh boy, I almost showed attendance again. Oh man. Wolfram Alpha. Hi. All right, so let's just, do I remember how to do this? No, we'll just say find the inverse. Find the inverse. Thank you. Y is equal to 5x minus 3 divided by the quantity. I also should make sure I put this in parentheses. 2x plus 1. Will it do as I ask it to do? Why, yes. And we get the same result. Right, that's good to know, right? So this is how to check your answer. I know it's terrible. I should not teach you these things. But I get it. So we get the exact same answer, which is good. So now let's discuss how to find everything else. All right, so let's find everything else. So what else is it asking us to find? Let me zoom back out. I guess I gave myself more room than I really needed. All right. Oh, wow. Wolfram Alpha is so nice for us. It actually graphed the two functions for us. Here's one, here's the other. Look. So here's the graph. You just click on that one. You can do it in Desmos as well. That just saves me a step. So we graph both of them on the same axis. So we've done. So let's check off what we've done real quick. Let me just check off what we've done. We found the inverse. Check. We graphed them both on the same axis. Check. So we need to find the domain and range. And so we're going to have the domain of f, and we're going to have the range of f. We're going to have the domain of f inverse, and we're going to have the range of f inverse. And let me tell you something that let me write this slightly different so I can draw stuff where I want to draw stuff. So let me put range of f, and then we'll put range of f inverse. All right, so here's the domain of f. So here, I'm allowed to put anything except anything that will make the bottom part here 0, right? So if I put in minus a half, right, that makes this 0. Or in other words, let me show you. 2x plus 1 cannot equal 0, right? Because I can't divide by 0. It's the only problem we'll have here. Well, that's going to mean x cannot equal minus a half if you solve through it. So here, I'm going to go from minus infinity to negative half union minus a half to infinity. So just everything but a half, right? The domain of f inverse, is the following. I can have, this cannot equal to 0, right? So I can have 2x minus 5 cannot equal to 0, right? And so in this case, x cannot equal 5 halves. And so here, we're going to go from minus infinity to 5 halves, union 5 halves to infinity. Okay. Now, the domain of f is the range of f inverse and the range of f. And so here, this just goes here. So you just plug it in here. This is the range of my function, is the domain of my inverse. And so how you do this is you find the domain of f, just make this not 0. Find the domain of f inverse, make this, find everything, make that not 0. And then you just swap it in. And I'll show you. And that's how it was before. I'll remind me at the end and I'll show you. And so that's how you do that one. Okay. So how you do this problem? Once again, we'll just run through the steps real quick. You're going to write y equals, swap your x's and y's, solve for y again, and it follows basically the same steps. You're going to multiply this across, right? This across, you're going to distribute your x, you're going to move your x, you're going to move your y over and move the x over and then divide out. It's always the same for this type of problem. If you see a monomial over a monomial, or basically x minus something or x plus something. And so it always ends up being this. And then you're going to just say, hey, that's end of inverse. You're going to write it in. You're going to graph the two and pick the right graph. For now, just use a graphing calculator. And or in this case, Wolfram Alpha or Desmos. Here, the domain of f is everything. So I can put anything up top, but I cannot have a 0 on the bottom. So I just set that, say, not equal to 0. That means x can't be at negative half. Notice I put negative half in here, I get a 0, so that's bad. So when I get that, that's the domain of f, and also it's the range of f inverse. Then for the domain of f inverse, we find where the denominator equals to 0, and we say we can't have that. So this cannot equal 0. We solve for that, we get 5 halves, and so everything but 5 halves. And so the way we do that is we write it this way: negative infinity to 5 halves, not including it, and then from not including 5 halves to infinity. So this is basically everything but 5 halves. And that is also the range of f. Okay. So, all right. Oh, one of us says you can't see what you are doing. Is it too small, or is it just not showing? Can everyone else see the screen? If I've been going on talking to nobody, nothing is happening. Oh, you can just see. You only see my tiny little cursor moving around as I'm re-explaining the problem. You're not seeing writing, right? Can you see writing now? Yeah. So I have my little cursor explaining the problem again to you, but I guess it's just not that visible to you guys, so I should make marks. Yeah. Okay. 10-4. Good to go. I just wanted to re-explain the whole steps with it all in front of you. I don't know why. All right, let's do the next. So these two are fairly simple and quick, so let's just do them. And let's go ahead. I need to go back to this. Let's make my cursor a little bit larger again. I don't need it so small. So here, these two problems, you'll see. No, we can't see the cursor. Yeah, it's probably too small for shooting across. All right. I'll make sure to make extra marks and then remove them. All right. Goodbye. What am I looking for? I'm looking for this. All right. So these two problems invoke this theorem right here. So this theorem right here. So we're going to have either log base a of x is equal to x, or log of a of x is this. So these are what we're going to be using. So here, log base e of e to all this means, so simplify this. So log base e of e to the absolute value of, oops, let me make that a tiny bit smaller, 2x minus 3 is just equal to 2x minus 3. For this one, log base 10 of log with nothing on it means, so log of nothing means log of 10 of b means here, if I'm raising this to that power and that, they just cancel and I get b. And so these are just asking the same question. You'll see a couple of these on the homework, or on the exam, not the homework. So that's all it is. It's just wants you to invoke the inverse rules. And I'll open that up again. So notice here, if we have log base a of x, it's just x. So here, if we have log base e of e raised to the absolute value of x minus 3, well, it's just or 2x minus 3, it's just the absolute value of 2x minus 3. And if I have log of a of x, that's just x. So I have 10 raised to the log of nothing, which is log base 10 of v, that's just v. So it's just using these two properties right here. All right, so the next one, let's solve ourselves an exponential equation. So here we have this. And so how we're going to solve this, we're going to take log of 2 on both sides. So I'm going to take log base 2 of 2 to the 2x minus 1 equals to the log base of 2 to the 8. And so here I want to clear out my exponent. And so this equals just 2x minus 1. And log base 2 of 8 asks the question, 8 raised to what power, or 2 raised to what power is 8? Yes, 2 raised to what power is 8? And log base 2 of 8 should be what, guys? What's log base 2 of 8? we all forgotten? 3. Yes, it should be 3. Now, if you're completely lost, let me show you how to type in a log again. Just because some of you to be log. So remember how to type in a log. So yes, it is 3. So log base 2, you just type in _2, and then you put in the 8, and it'll solve it for you. And you get it again, 3. But remember, this asks 2 raised to what power is 8? And then, of course, is 3. Okay. So either way, so what do we have? We have 2x minus 1 is equal to 3. And then we'll just solve it. So we'll have 2x is equal to 4. So that means x is equal to 2. And this one we can easily check. 2 raised to 2 times 2 minus 1. Is that equal to 8? Well, 2 times 2 minus 1 is just 2 raised to the third power. Is that 8? Yes, it is. Okay. All right. Here we have a log equation. And so in this case, they'll give you this one. So what they want you to do is they want you to combine these. So I have this minus this. So it'd be x plus 24 divided by x plus 1 equals the log of 13. Now here, since I have logs on both sides, I can just exponentiate both sides. So I'm going to exponentiate to 10 because this is log base nothing, so it's log base 10. If it has nothing, it's log base 10. And so this just becomes x plus 24 over x plus 1 equals 13. And this, hold on, let me put a little box around it. This is the one where it says do not solve for x, just clear the logs. That's what you're typing in. Does that make sense? Remember I showed you it says what the half step? This is the half step. Okay, so type that in. And then just to solve it, you're just going to put x plus 24 equals 13 times x plus 1. And then here you just solve this out. So let's do that. So I'll have x plus 24 equals 13 x plus 13. So I'll have x equals, hold on, let me not skip that many steps. Let's just do, let's move this 13 over. So I have 11 equals 12x, so x equals 11 twelfths. Okay. And once again, you can type all this happening and turn this into Wolfram Alpha and double check it. So let's do that. I have log x plus minus log. Oh, please remember Wolfram Alpha thinks log based nothing is log based e. So put in log base 10. X plus 1 equals log of 10 of 13. Was that what we had? The problem is I've written it. Okay. Okay, so here it is. It interprets it correctly. And here we get 11 twelfths. Okay, so we checked our solution. Does that make sense how to check our solutions? I'm trying to teach you how to check your solutions. That way you have like 0 happy fun issues. Okay. All right, and there we go. And now we have, and that's the end of this page. All right, so we've been going for a good 50 minutes. So we'll do the other 2 pages next time. There's a hummingbird out my window. You don't love hummingbirds. All right. So we're on problem 7. So let's just pick up here. Let me zoom in. I'm already zoomed in. Let me put a little star so I know how to start. All right, so here. So given that log of n of 3 is equal to 0. Just equal to this. Log of n of 4 equals to this, and log of n of 7 equals to this. Find log of n of 4 divided by n. So how do you do this problem? Well, here we're just going to take the log of n of 4 divided by n, and we're going to split it. And we're going to write that this is the log of n of 4 minus the log of n of n. And here we're just using, let me open up my rules. Hi, I want my rules back. 5-4, I think. Wrong rule. Wrong rules. No, no. Oh, it's 5-5. No, I'm like, none of this makes sense. Why is this being so weird? I had them literally a few minutes ago, and now they're gone. I literally lost them. Oh well. So here we have the rules. So division turns into subtraction. Here, do we know what this is? Yeah, we know what this is. It's right here. It's 1.135. Do we know what log base n of n is? Yeah. Log of n is 1. Or n raised to what power is n? 1, right? So this is 1. And so this is just 0.0135. Okay. All right. Sure. Let me do that. And also let me, oh. Uh-oh. Uh-oh. There's only one way to do this. Quick. New page. Everything go bye-bye. There we go. All right. So that's how this one works. And so does everyone see, is any questions on how this one goes down? So let's do the next two. So the next two we're going to convert. So here we're just using the division turns into separation, and then we use log base n of n is 1, and we pull this. That means that these two informations right here are just red herrings, and so they're not super useful for us. So here we're going to convert logs and log equations into this, and so remember that a to the x equals b is equal to, or is the same thing as saying log base a of b is equal to x. Okay, and so we're just going to use this here to rewrite all these. And so here we'll have log base 2 of 16 is equal to x. Here we'll have log base 10, or you could left it out, right, of 0.001 is equal to -3. And does that make sense? Yeah. 10 raised to what power is 0.001? Well, that's -3. And the last one here is log base e, or we could write ln of 70 is equal to t. Okay, so here's just, do you know how to go from here to here, and then from here we'll just be going from here to here. And so this would be 2 to raise to the 6th power is 64. This one is a raised to the 4th power is b, and this one is c raised to the x power is capital Y. Okay, and so it's just getting used to going from here, from the exponential version to the logarithmic version. Okay, so if it's base a, it's still base a, and here the exponent is what it equals, and what it equals is what you put into log. Okay. Okay, for number 7, if it was, yeah, so good question. For number 7, if it was it was 7 over n, we would use this, right? So we use this one if it was 7 over n. But here it's 4 over n. Yeah, so whatever this number is here is what number it was, which note where you pull from there. Okay. All right. All right, so hopefully you've written all these down. Any questions on converting logs to exponents or exponents to logs? My friend who came late, I gotcha. No. Okay, let's go on down. All right, so let's solve this one. This one takes a little bit, so let's do it. So notice here we have two different exponents, right? I have exponent something a 5 base and then a 3 base for my exponent. So in this case, we just take the natural log of both sides. So here I'll have ln of 5 of 2x to the minus 1 power equals ln of 3 to the 3x plus 2 power. And then we're going to use our power rule. So we can pull this out. So powers become multiplication. Oops. 3x plus 2 ln of 3. So here we have powers become multiplication. Then we just distribute. So we'll have 2x ln 5 plus ln of 5 equals 3x ln 3 plus 2 ln 3. So I'm just distributing. Remember that ln of 5 and ln of 3 are just some numbers. We're going to leave them generic for now, but we'll look a little more like an x. All right, so here we're going to move all the x's to one side, all the constants to the other. So I'll have 2x ln 5 minus 3x ln 3 equals minus 5, or minus ln of 5 plus 2 ln 3. So here I just move this one over here, move this one over here. Then we're going to factor out our x. So I have x equals 2 ln 5 minus 3 ln 3 equals minus ln 5 plus 2 ln 3. And then we just divide it out and we get our final answer. Oops, that didn't do what I wanted to do. No, don't do that. I said move all of it. There we go. And we get our final answer here, minus ln of 5 plus 2 ln 3 over 2 ln of 5 minus 3 ln 3. Okay. Would it be? Oh, he was very, very correct. So if this is minus 1, hold on, let's make that change. Thank you. Because this is minus 1. Thank you. Thank you for pointing out my error. I copied it down wrong. This becomes positive. This is positive, and this is positive. Okay. All right. Now, let's check it. Just open up me Wolfram Alpha. Hold on. It's going to make a terrible video today. My brain just died like 4 times. All right, so let's type that in. So it's positive ln 5 plus 2 ln 3. I bet I can, no, that's good. Divided by 2 ln 5 minus 3 ln 3. I didn't put parentheses in. All right, so this is what we have here. So log, remember that Wolfram Alpha thinks log is log base e, which is not what it is for the book. And so here I get minus 49.6 something. Okay, so that's what you're going to type in. I think it wants up to 3 decimal points, so you'll type in minus. So let's just go and write that up to 3 decimal points. So it'll be x equals minus 49 point. Uh-oh, my memory didn't pick it up. Memory. 462. 462. Okay. And we can double check this. We can double check this using. We can just type it straight in. Hi, thank you. Ta-da. And so here, if we just type it straight in, here we have x to the 5 to the x minus 1, 2x minus 1, 3 to the 3x plus 2, and it gives us this. And you just hit the approximate button, and presto, we get the same answer. Okay. So here we can check it twice. So do it by hand, do it in the computer, double check it, and then plug it in. Okay. All right. I'll take a drink and let you copy that down. We'll go from there. All right. Let's just do our last page. All right, so now we want to solve this. And so this is just like a normal log equation. So the first thing we want to do is combine the logs into one. So we're going to have log base 2. Remember, addition becomes multiplication. So x plus 1, x minus 1 equals 3. So that's the first step. The second step is we want to raise everything to the second power. And so I usually just do this as shorthand. Just write 2 to all this, 2 to all this. Well, 2 to the third is 8. And 2 of log base 2 is just whatever's up top. So this would be x plus x plus 1, x minus 1. Yeah. So this cancels this. This turns into 8. So here we need to resolve this. So this becomes x squared minus 1 equals 8. Move the 8 over. Do not set x plus 1 equals 8 and x minus 1 equals 8. Do not do that. I see people do it all the time. Don't do it. Resolve it. So we get x squared minus 9 is equal to 0, which means either x is equal to, so it's x plus 3, x minus 3 equal to 0. So either x is equal to negative 3 or 3. Now remember, you need to check these. You have to check it in domain. So check domain, aka no negative logs. Okay, no negative logs. So here, if we plug in negative 3, if I take negative 3 and plug it in here, I'm going to have negative 3 minus 1, which would be minus 4, which does not work. So I cannot have this one. Negative 3 doesn't work. 3 works because 3 is 4 and 2. And so 4 and 2 work fine. Negative 3 does not work because it gives me a negative log. So it's not in the domain. Okay. And so the answer here is only x equals 3. If you plug in x minus 3, it's going to give you a wrong answer. Okay. Because it is wrong, right? So just be careful. Remember to check domain, aka no negative logs. And this appears on your exam. So just be careful of it. All right. Let's do the last 2 questions. My little bracket thing broke. I don't know why it broke, but it broke. So these are together. So I'm going to use elimination. So here I'm going to call this equation 1, call this equation 2. I'm using elimination. I'm going to just multiply equation 1 by 3. So I'll have 3 times equation 1 and I have equation 2. So I'll have 15x plus 3y minus 21. And we'll have 7x minus 3y equals minus 45. We'll just add these 2 up. I'll get 22x, 0, and minus 66. So that means x is equal to minus 3. And then here I'll just plug that back into 1. Oops. No. 1 blue. It's gonna be mean on me today. Why do you hate me today? I want blue. Okay. There we go. Oh man, these are gonna be funny notes. So I'm just gonna replug that into 1. So I have 5 times minus 3 plus y equals to negative 7. So minus 15 plus y equals to minus 7. So y equals to 8. So I have my solution here, minus 3, 8. And the system is consistent. So it's consistent because it has a solution, right? It has a solution. And the equations are independent. Independent, meaning one is not a multiple of the other. Okay. So it's consistent and independent. And consistent independents have one solution. So if you have one solution, it's consistent and independent. I will show you on the next one right here. On the next one, I'll show you both the other two cases. So let me go ahead and split this. And in fact, let's just do 2 problems. We're going to do this one, and then we're going to do one very, very, very similar to it. It's just I'm going to change what the constant is. All right, so we're going to do both this one and this one. So we'll actually do 2 problems. So in this one, I'm going to do elimination. I'm just going to multiply this one by minus 2. So I have 1 minus 2 of equation 2, right? So I'll get 12x minus 10y equals 2. And then I'll have minus 12x plus 10y equals minus 6. Add these up, I get 0, 0, minus 4. So 0 equals minus 4. That's no solution, right? No solution. Which is inconsistent. Inconsistent. However, these equations are still independent. Okay, because one's not a multiple of another. Here, notice that if I multiply this equation, if I multiply equation 2 by 2, I'll get equation 1. And what happens here? Let's actually just do that. So we'll have 2. Let's just have equation 1 times 2 equation 2. And here I'll get 12x minus 10y equals 2. And then I'll have negative 12 because I want to get rid of it. X plus 10y equals minus 2. Here I get 0 equals 0, right? And so this is infinitely many solutions. So this is infinite solutions. Okay. And then with those infinite solutions, so this is consistent. Why? Because it has a solution, right? It actually has infinite, but that means infinite or 1 is still consistent. Now, in this case, it's dependent. And why? Because equation 2 is a multiple of equation 1. Okay, if I take 2 of equation 2, I get equation 1. So it's dependent. And the solution set here would be x, and then I just solve this for x. So here I'll have minus 5y equals minus 6x plus 1. So I'm just taking equation 2 and solving it, and then I'll have y equals 6/5 minus 1/5. And so, x, I've got my x here, so it'll be minus 6/5 x minus 5th is my infinite number of solutions. So given an x, my y is the following, right? Okay. So that's it. That's it. Okay, let me mark my little friend who came late is here. All right. Boop, boop. All right, you're all marked as here. And let me show you how to do a system real quick. History. Why ask my name? Pull it up. And how do we check these in the computer? We're just going to just open up Wolfram Alpha, and here we can just type in log. Oh, hold on. My not my search bar here. Type log base 10, and we'll just check each of these. So we'll have x plus 1 plus log base 10 of x minus 1 equals, gee, what was it? Oh, it wasn't base 10, it was base 2, wasn't it? That's right, base 2. Base 2. And we have a 3 here. I remember what the first problem was. Yeah, and notice here, if we type this into Wolfram Alpha, we pump out our one solution. Okay, so that's how we check that one. Here, if we want to check the system of equations, we'll just type in system of 2 equations. There we go. And we'll just type each one of these in. So we'll have, what was it, 5y, or no, 5x plus y equals minus 7. And the other one was, hold on, let me scroll up so I can see it. 7x minus 3y equals minus 45. And we'll just hit compute. We get our answer here, minus 3 and 8. We'll type in the other two we did. So we have 12x minus 10y equals 2. And then we'll have 6x minus 5y equals 3. We hit compute. And we have no solutions. And if I make this equal to 1, which is our other option right here, hit compute. And we get our result of y equals this, right? So it gives us the result of, here's our infinite solution. It's just in the form of x, and then y is equal to that. Okay, so anything along this line solves. And that's it. All right, can you go through which sections the problems are so we can match the notes from the homework so we can figure out? I can't figure out. Oh, can we go which sections which? Sure. Let's see if I can't do that real quick for you. All right. So this, see if I can pull this out real quick. So I'm pretty sure that this is, all right, so these two are section 6.1. Okay, so I'm just going to put like 6.1. 6.1. Okay, so 12 and 13 come from 6.1. 11 is, I think, 5.5. All right, so 5.5 is where we do the exponential and log equations. So 11 here is 5.5. And 10 here is 5.5. I think it's 5.3. Yes, so 5.3 is where we do the converting from log to equations and back again. Okay, so that's 5.3. So let's go here. This is 5.3. This is 5.3. This is your log rules, so that'd be 5.4. Okay. And here, this is solving a log equation, so this is 5.5. This is solving an exponential equation, so 5.5. This is your log rules, and so this is 5.3. Both of these are 5.3. And then we'll hit the first page real quick. This is 5.4. This is your log rules. This was 5.1. This was your inverse. And this is 5.4, which were your log rules. Okay, so that's each one of each section. So technically it's over a lot of sections, but remember how I said most of last week was homework? I wasn't lying. All right, so I'm going to put a happy star here.